The sky conceals wonders most people never see. This journey reveals 25 rare astronomical events you should not miss, cosmic spectacles that can define a lifetime of stargazing. You will discover the secret schedules of the heavens and learn exactly when and where to look for these fleeting marvels. We will uncover how a dying star can suddenly outshine a galaxy and why the moon sometimes turns to blood. What celestial sight has permanently changed your view of the universe? A shadow races across the Earth at over 1,000 miles per hour, a perfect cosmic alignment unfolding in absolute silence. This is a total solar eclipse, the sky's most dramatic spectacle. It begins subtly with a small bite taken out of the sun's brilliant disk. Over the next hour, that bite grows, the daylight fading into a sickly, metallic gray. The world holds its breath, then in the final seconds, the last sliver of sunlight vanishes. Day becomes night, stars pierce the twilight sky, and the temperature plummets. All around you, animals fall silent, confused by the sudden, false sunset. But the true miracle is what hangs where the sun should be. The moon, in perfect alignment, reveals the sun's ethereal corona, a pearly white halo of superheated plasma stretching millions of miles into space. It is a sight of profound and humbling beauty, visible only from a narrow path on Earth called the totality zone. Millions witnessed this in 2017 when the moon's shadow swept from Oregon to South Carolina. Another chance arrives on April 8, 2024, when a new path of totality will arc from Mexico through Texas and up into the northeastern United States. To stand in that path is to experience a moment where the clockwork of the solar system becomes visible, a memory that will stay with you forever. While a solar eclipse plunges the world into temporary night, another alignment offers a more subtle but equally profound cosmic performance. Picture a tiny, perfectly black dot crawling with impossible slowness across the face of the sun. This is the transit of Venus, an event so rare it has not occurred in over a decade and will not happen again for more than a century. It is the ultimate exercise in celestial patience. For hours, the planet Venus passes directly between the Earth and our star, its silhouette a stark, moving blemish on the solar surface. This is not a spectacle of darkness, but one of perfect geometry and scale, a reminder that even our closest planetary neighbor is a distant world. The rarity of this event is staggering. Transits of Venus occur in a precise pattern, with pairs of events 8 years apart separated by gaps of over 100 years. The last pair happened in 2004 and 2012. The next will not grace our skies until the years 2117 and 2125. To witness one is to participate in a legacy of discovery that reshaped our understanding of the cosmos. Centuries ago, astronomers realized that by observing a transit from different points on Earth and timing Venus's journey across the sun, they could triangulate the distance to the sun itself. These expeditions were the space missions of their era, sending scientists across the globe to capture data that would finally pin down the vast scale of our solar system. To safely watch this historic event, you must never look directly at the sun. Proper solar filters for telescopes or certified eclipse glasses are absolutely essential to protect your eyesight. Seeing that small, dark dot against the immense solar disk connects you to generations of stargazers who used this same sight to measure the heavens. It is a quiet, patient marvel, a cosmic clock that ticks only once in a lifetime, or even just once in many lifetimes. The silent clockwork of planetary transits gives way to a far more flamboyant visitor from the deep freeze of our solar system. Every so often, a great comet arrives without warning, a cosmic snowball of ice and rock that ignites the night sky with a brilliance that can stop you in your tracks. Unlike the predictable, dim comets astronomers track, a great comet is a rare and spectacular event. It grows a tail millions of miles long, a shimmering river of dust and gas that can stretch across a quarter of the sky. plainly visible to anyone who simply looks up. Comet Hale-Bopp was one such marvel, a celestial celebrity that graced our skies for an incredible 18 months in the late 1990s. It was so bright it could be seen even from light-polluted city centers, a constant, ethereal presence that captivated the entire world. More recently, Comet Neowise appeared in the summer of 2020, a surprise gift during a difficult time. It offered a breathtaking pre-dawn display, its distinct fan-shaped tail a sight of pure cosmic magic that brought people together in shared wonder. The true magic of a great comet lies in its unpredictability. These are often first-time visitors from the distant Oort cloud, a vast shell of icy bodies at the very edge of our sun's gravitational influence. A chance gravitational nudge sends one on a long fall inward, and as it approaches the sun, its ices heat up, erupting into a giant glowing coma and those magnificent sun-pointing tails. You might have weeks or even months to observe it, watching as it slowly changes position night after night. There is no schedule for these events, no way to know when the next one will arrive. It is a sudden, brilliant interruption to the familiar patterns of the night, a reminder that our solar system is still a place of dynamic and beautiful chaos. This cosmic drama unfolds closer to home, where our own moon can transform into a stunning coppery orb. A supermoon lunar eclipse is a celestial double feature, a spectacle of alignment and light that paints our familiar neighbor in an entirely new color. It begins with the supermoon itself, when the full moon reaches the point in its oval-shaped orbit that brings it closest to Earth. This proximity makes the moon appear noticeably larger and brighter in our sky, a radiant prelude to the main event. Then the eclipse commences. You will see the round, dark shadow of our own planet begin to creep across the moon's brilliant surface. This is not a sudden disappearance like a solar eclipse, but a slow, graceful dimming. As the shadow completely envelops the moon, something magical happens. Instead of vanishing into blackness, the moon glows with a deep, fiery red. This is the blood moon, a sight that has captivated and sometimes frightened humanity for millennia. The science behind this color is a beautiful trick of our own atmosphere. When the moon is in Earth's shadow, no direct sunlight can reach it. However, sunlight skimming the edges of our planet passes through the blanket of air surrounding us. Earth's atmosphere acts like a lens, bending this light and also scattering away the shorter, bluer wavelengths. What remains is the red part of the spectrum, which is projected onto the surface of the eclipsed moon. It is as if you are seeing the light of every sunrise and sunset on Earth, happening all at once and being cast upon the lunar surface. This combined event is so visually dramatic because it merges the moon's imposing supermoon size with this surreal, otherworldly coloration. The ordinary becomes extraordinary. You are not just looking at the moon, you are witnessing a demonstration of our planet's place in space, its atmosphere painting a portrait on a cosmic canvas. The next time you hear that a supermoon lunar eclipse is coming, make a plan to step outside and watch this slow, silent theater in the sky. Sometimes the slow dance of the planets aligns for a breathtakingly intimate performance. A planetary conjunction occurs when two or more worlds appear to draw incredibly close together in our night sky, a celestial illusion of proximity that can create some of the most beautiful and accessible sights for any stargazer. While these planets remain millions of miles apart in the vastness of space, from our vantage point on Earth they seem to nearly touch, merging their light into a single, brilliant beacon. The Great Conjunction of Jupiter and Saturn in December of 2020 was a perfect example. For weeks, the two gas giants edged closer each evening, until on the night of closest approach they were separated by just a fraction of the moon's diameter. Through a small telescope, you could see both planets and their moons in the same field of view, a stunning double feature that had not been that tight since the year 1623. Spotting these events is wonderfully straightforward. You need no special equipment, just a clear view of the western or eastern sky after sunset or before sunrise, depending on the planets involved. Apps and simple star charts can guide you, but the true magic is in the simplicity of watching these bright, steady points of light converge. Their glow is unmistakable against the twinkling stars. While conjunctions between bright planets like Venus and Jupiter happen every few years, the truly close encounters, the ones that take your breath away, are far less common. Some pairings are separated by decades. This makes each significant conjunction a unique photographic opportunity. Against a twilight sky or with a striking landscape in the foreground, the close pairing of worlds creates a composition of pure cosmic elegance. It is a reminder that the solar system is in constant, graceful motion, and that sometimes its choreography puts on a show just for us. The quiet elegance of planetary alignments can suddenly erupt into a celestial fireworks display of unimaginable intensity. A true meteor storm is not the gentle shower you might watch on a summer night where you see a few streaks per hour. This is something else entirely, an event where the sky itself seems to come alive with thousands of meteors, sometimes tens of thousands, flashing across the heavens every single hour. It is a rain of fire, a silent, breathtaking cascade of light that can feel both exhilarating and humbling. The difference lies in the source. Regular meteor showers come from the diffuse, sandy debris left behind by comets. A storm, however, occurs when Earth plows directly into an exceptionally dense and narrow ribbon of rubble, a fresh trail of pebbles and dust that a comet ejected during a past visit. Think of the difference between walking through a light mist and standing directly under a waterfall. The most legendary example is the Leonid storm of 1966. Eyewitnesses in the southwestern United States reported a peak rate that reached an incredible 40 meteors per second. The sky did not just have streaks of light, it was filled with them, a dizzying, overwhelming spectacle that looked less like falling stars and more like the sky was dissolving. Predicting these storms remains one of astronomy's great challenges. It requires pinpointing exactly where a comet's ancient debris trail will intersect with Earth's orbit, a calculation complicated by the gentle push of solar radiation and the gravitational tugs of planets. When the predictions are correct, the reward is a display of raw cosmic power that is utterly unforgettable. To witness a meteor storm is to see the ghost of a comet, the leftover grit from its long-gone passage, flaring into incandescent vapor as it hits our atmosphere at over 100,000 miles per hour. It is a temporary, brilliant scar across the sky, a reminder that our planet is constantly moving through a dusty sea of ancient construction material. The silent rain of a meteor storm is a spectacle born from cosmic dust, but the sky can also ignite with living color drawn from the sun itself. There are moments when the legendary northern and southern lights abandon their polar domains and surge toward the equator, painting the skies over cities and countries that almost never see them. This is a low-latitude aurora, a celestial invasion of shimmering greens, deep reds, and ethereal purples that dances where it does not belong. These curtains of light are not magic, but the result of a violent argument between the sun and Earth's invisible shield. Our sun constantly exhales a stream of charged particles, the solar wind. Normally, our planet's magnetic field, the magnetosphere, deflects this wind toward the poles, where it energizes gases in the upper atmosphere, causing them to glow. But during a powerful solar storm, when the sun unleashes a colossal bubble of plasma called a coronal mass ejection, the rules change. This immense wave of energy slams into our magnetosphere, stretching and distorting it. The protective field is overwhelmed, allowing solar particles to pour into the atmosphere at much lower latitudes. The result is an auroral display that can be seen from Texas, Italy, or even Mexico. The colors tell a specific story. The classic shimmering green comes from energized oxygen atoms high in the atmosphere. The rarer, deep red hues come from oxygen at even higher, thinner altitudes. And the elusive purple ribbons are the signature of nitrogen. The most extreme example in recorded history was the Carrington event of 1859. Named for the astronomer who observed the massive solar flare that triggered it, the resulting geomagnetic storm was so powerful that auroras were reported in the Caribbean, and so bright over the Rocky Mountains that gold miners woke up and started making breakfast, convinced it was morning. The event was so intense that it caused telegraph systems across Europe and North America to fail, with sparks flying from the equipment and some operators even receiving shocks. To witness an aurora far from the Arctic Circle is to see a direct and beautiful consequence of our star's tempestuous nature, a visible crack in our planetary defenses that reveals the raw power flowing from the sun. The same planets that dance in close conjunction can also perform a perfect cosmic vanishing act. A planetary occultation occurs when a planet moves directly in front of a distant, bright star, blotting it out of the sky with the precision of a celestial light switch. This is not a gradual dimming, but an instantaneous disappearance, as if the star was never there at all. The most stunning example is when Venus, our brilliant evening star, glides in front of Regulus, the brightest star in the constellation Leo. One moment you see two points of light nearly merged into one, and the next, the fainter one, is simply gone. Then, just as suddenly, it pops back into view from behind the planet's opposite limb. Observing this requires careful timing and a good telescope, as the event is incredibly brief, often lasting only a minute or less. Predicting such a perfect alignment is a monumental feat of celestial mechanics, demanding an exact understanding of the orbits of both Earth and the distant planet. The path on Earth from which this event is visible is often only a few dozen miles wide, making it a true chase for dedicated astronomers. But why go to such trouble? The scientific payoff is immense. By watching how the star's light fades and reappears, scientists can probe the atmosphere of the planet itself. If Venus has a dense, hazy atmosphere, the star will dim more gradually as it passes behind it, rather than snapping off instantly. This single, fleeting observation can reveal the temperature, pressure, and composition of an alien sky millions of miles away. To witness a planetary occultation is to see our solar system used as a giant laboratory, where a distant star becomes a probe and a passing planet becomes the subject of a grand experiment. An event in deep space can unleash more energy in 10 seconds than our Sun will produce across its entire 10 billion-year lifetime. This is a gamma-ray burst, the most powerful known explosion in the universe since the Big Bang itself. For that brief, unimaginable moment, a single object outshines every star in its home galaxy. But the main event, the initial flash of high-energy gamma radiation, is invisible to our eyes. The real treasure for skywatchers is what comes next, a rapidly fading afterglow that can sometimes, just for a few hours, be seen with powerful amateur telescopes. This afterglow is the cosmic equivalent of a cooling ember. The visible and radio waves generated as the blast wave from the explosion slams into the thin gas of interstellar space. When astronomers get an alert from a satellite like Swift or Fermi, which are designed to detect the initial gamma-ray pulse, a global race against time begins. Observatories around the world and in orbit immediately swivel to the coordinates provided, desperately trying to capture the fading light across every possible wavelength before it vanishes forever. The sources of these cataclysms are as dramatic as the bursts themselves. Long-duration gamma-ray bursts are thought to be the birth cries of black holes, signaling the collapse of a massive, rapidly spinning star into oblivion. Shorter bursts are the result of a different kind of violence, the final, fatal embrace of two ultra-dense neutron stars spiraling together and merging. In 2017, the detection of a gamma-ray burst from a neutron star merger was accompanied by the first ever observed gravitational waves, opening an entirely new era of multi-messenger astronomy. To catch a glimpse of an afterglow is to witness the final, visible echo of a stellar catastrophe, so vast it defies human comprehension. a fleeting signature of creation and destruction happening in the darkest reaches of the cosmos. Our own moon can perform a similar celestial sleight of hand, eclipsing a world right before your eyes. A lunar occultation of a planet is a stunning demonstration of orbital motion in real time. You watch as the moon, that familiar silvery disk, drifts inexorably toward a brilliant, steady point of light like Jupiter or Mars. The approach is slow, almost hypnotic. Then the moment of contact arrives. The planet does not simply wink out. Instead, it seems to press against the moon's dark, unlit edge, holding its ground for a few seconds before being slowly, silently swallowed by the lunar surface. It vanishes not into shadow, but behind a physical barrier, a mountain of rock 250,000 miles away. The disappearance is gradual and utterly mesmerizing. The real magic, however, is the reappearance. You wait, your eye glued to the telescope, knowing exactly where to look along the bright, sunlit limb of the moon. Suddenly, a brilliant point of light flashes back into existence, growing steadily brighter as the moon continues its journey across the sky. This event offers a uniquely clear view of the moon's profile. Because the moon has no atmosphere to distort the view, the planet's disappearance and reappearance happen with razor-sharp precision, revealing the actual topography of the lunar limb. You are not seeing a smooth circle, but a landscape of mountains and valleys in silhouette. The timing is critical, as the path of visibility for a specific planet's occultation can be incredibly narrow, sometimes only a few miles wide. This makes seeing one a special prize for careful planners. To witness a bright planet be erased and then restored by our celestial neighbor is to feel the clockwork of the solar system in your bones, a perfect alignment made personal and profound. That same atmospheric lens that paints the moon red during an eclipse can also perform a far more fleeting magic. A brilliant green flash can crown the setting sun, a final emerald farewell that lasts for only a few seconds. This is not a myth or a trick of the mind, but a precise and beautiful consequence of light bending through our planet's air. As the sun dips below a distant horizon, its white light is being refracted or split apart, much like light passing through a prism. The atmosphere acts as this prism, separating the sunlight into its constituent colors. The shorter wavelengths, blues and greens, are bent more strongly than the longer red and orange ones. For a moment, just as the sun vanishes, the blue light is often scattered away by the atmosphere, leaving the green to dominate. You see a spot of pure, vivid emerald light sitting atop the disappearing solar disk, a final, brilliant jewel before the darkness settles. Catching this phenomenon demands perfect conditions. You need an exceptionally clear, unobstructed horizon, which is why it is most often reported over the ocean. Any haze, clouds, or distant hills will scatter that precious, focused green light and ruin the effect. It requires patience and a steady gaze, watching the sun set without looking directly at its intense, damaging light until the final sliver remains. The reward for this vigil is a moment of pure, concentrated color that feels like a secret shared between you and the physics of the planet itself. It is a transient gift from the air we breathe, a final, brilliant punctuation mark at the end of the day. Even Halley's Comet, a predictable visitor, leaves behind celestial landmines in its wake. The Eta Aquariid and Orionid meteor showers are its two annual gifts, but in certain years these gentle rains explode into fiery outbursts. These are not random events, but the direct result of our planet plowing through a particularly dense and untouched ribbon of rubble that the comet ejected centuries ago during one of its ancient passes near the sun. Imagine a garden hose lying coiled on the lawn, with the thickest, most concentrated stream of water trapped within its loops. Earth's orbit typically only grazes the outer, more diffuse spray of Halley's debris. But when our path intersects one of those dense, coiled loops, the result is a meteor outburst where rates can surge from a respectable 20 or 30 meteors per hour to a dazzling 60, 80, or even more. The Eta Aquariids peak in early May, favoring the pre-dawn hours of the southern hemisphere, while the Orionids grace the northern hemisphere in late October. The meteors themselves are famously fast, a legacy of Halley's own breakneck orbit, and they often leave behind glowing trains of ionized gas that linger for a second or two after the meteor itself has vanished. Predicting which year will bring an outburst is a complex puzzle. Astronomers must calculate the gravitational dance of these specific debris trails, nudged not only by the planets but by the gentle, constant pressure of sunlight itself. A trail ejected by Halley in 361 BC might be perfectly positioned for a rendezvous with Earth in 2046. This makes every Eta Aquariid or Orionid peak a potential treasure hunt. You never know if the year you decide to set your alarm for a cold, dark morning will be the year you witness the ghost of the most famous comet in history putting on a truly spectacular and unexpectedly brilliant command performance. A star can suddenly ignite where no star was seen before. This is a nova, a stellar explosion that forges a new point of light in a familiar constellation, visible to anyone who simply looks up. Unlike a supernova, which marks the violent death of a star, a nova is a stellar resurrection. It occurs in a special kind of binary system where a dense white dwarf star and a larger, normal star orbit one another in a cosmic dance. The white dwarf's intense gravity slowly steals hydrogen gas from its companion, pulling it onto its own scorching hot surface. This stolen fuel builds up for decades or even centuries, a pressure cooker of immense proportions. Eventually, the temperature and pressure at the base of this hydrogen layer becomes so extreme that a runaway thermonuclear explosion rips across the white dwarf surface. In just a few hours, the system can increase in brightness by a factor of 50,000, transforming a faint, invisible star into a beacon that can outshine its entire neighborhood. One of the most famous examples is Nova Cygni 1975. It appeared without warning in the constellation Cygnus, the Swan, blazing to a magnitude of almost 2, as bright as the stars in the Big Dipper. For a few glorious days, a brand new star shone in the summer sky, a celestial landmark that anyone could find. The most exciting part is that these events are often first spotted by amateur astronomers, dedicated sky watchers who know the patterns of the constellations so well that they immediately notice when something new has arrived. They are the Cosmic Patrol, the first alert system for these stellar outbursts. To see a nova is to witness a temporary rebirth, a brilliant flare of nuclear fire that reminds us the sky is not a static map, but a dynamic and ever-changing arena. That brilliant nova is a stellar eruption, but our own atmosphere can be set ablaze by a far more intimate visitor. An Earth-grazing meteor is a celestial rock that does not dive straight down, but instead skims the upper layers of our air like a stone skipping across a pond. It enters the atmosphere at an incredibly shallow angle, often just a degree or two above the horizontal. This geometry transforms a fleeting streak into a long, slow, majestic procession across the sky. Unlike the quick flash of a typical meteor, an Earth grazer can be visible for 30 seconds, a full minute, or even longer. You are not watching a sudden death, but a prolonged and glorious display. The meteor becomes a spectacular fireball, often glowing with intense colors of green, blue, or brilliant white as its surface material violently vaporizes. It leaves behind a glowing trail of ionized gas that can persist for many minutes, a ghostly scar marking its incredible journey. These events are so bright they can turn night into day for a brief moment and are frequently seen by people across entire states or countries, all sharing the same awe-inspiring sight. Their origin is distinct from the dusty debris of comets. Earth-grazing meteors are often chips from asteroids, more substantial pieces of rock and metal. Because of their shallow trajectory, many do not fully disintegrate. They simply use our atmosphere as a brake, slowing down just enough to be flung back out into interplanetary space on a new orbit, forever changed by its close encounter with our world. Others might survive the passage and continue on to impact the Earth elsewhere, sometimes producing powerful sonic booms that rattle windows and add a physical sensation to the visual spectacle. To witness one is to see a piece of another world not just falling toward us, but gracefully traveling alongside us, a temporary companion on its cosmic voyage. The slow, graceful dance of the planets sometimes brings them all together for a grand performance. A planetary parade is that rare occasion when several worlds align in a single, elegant arc across the sky, clustered so tightly you can sweep your gaze across them in one smooth motion. In the pre-dawn hours of June 2022, a spectacular lineup unfolded. For weeks, Mercury, Venus, Mars, Jupiter, and Saturn all gathered in a diagonal line, a celestial family portrait visible to the naked eye. Each planet held its own distinct character. Brilliant Venus shone as the unmistakable morning star, a beacon of pure white light. Mighty Jupiter glowed with a steady, creamy hue just to its east. Further along, Saturn appeared as a golden, tranquil point. Then came the reddish glint of Mars, and finally, the most challenging to spot, tiny Mercury hovering just above the horizon. Finding them is a rewarding exercise in celestial navigation. The best strategy is to find a location with a clear, unobstructed view to the east before sunrise or to the west after sunset, depending on the alignment. A simple stargazing app can confirm you are looking at planets and not just bright stars, but the true joy comes in learning to recognize their unique, untwinkling light. The science behind this beautiful arrangement is a matter of perspective. These planets are not physically lined up in space. They remain separated by hundreds of millions of miles. From our moving vantage point on Earth, however, we see them all projected onto the same plane, the ecliptic, which is the flat disk of our solar system. As we and the other worlds orbit the Sun at different speeds, our lines of sight occasionally converge, making it appear as if they are neighbors in a cosmic chorus line. While seeing 2 or 3 planets together is relatively common, a parade of 5 bright planets is a much rarer treat, an event that might only happen once or twice in a decade. It is a quiet, patient spectacle that reveals the elegant architecture of our celestial neighborhood, a reminder that you are standing on a platform hurtling through space, watching other platforms in their own majestic orbits. Even a star's steady light can be stolen by a silent, unseen wanderer. Far beyond the moon and planets, a small main belt asteroid, often just a few dozen miles across, drifts through the blackness on its own path. From our perspective on Earth, its journey can sometimes carry it directly in front of a distant, bright star. This is an asteroid occultation, a celestial event of perfect timing and profound subtlety. The star does not twinkle or fade gradually. For a few precious seconds, it simply vanishes, blotted out by a tiny, dark rock millions of miles away. Then, just as suddenly, it winks back into existence. This brief blackout is the only signal of the asteroid's presence, a ghostly transit that reveals what telescopes cannot see directly. Predicting these events is a triumph of modern astronomy. It requires knowing the orbits of hundreds of thousands of asteroids with extraordinary precision and pairing that data with the exact positions of countless stars. When the celestial math shows that an asteroid's shadow will sweep across a specific part of Earth, an alert goes out to a global network of amateur astronomers and citizen scientists. This is where the magic truly happens. The path of this invisible shadow is often only a few miles wide. By having observers spread out across this path, each with a telescope and a precise timer, the event can be captured from multiple points. One person might see the star disappear for 2 seconds, while someone just a few miles away records a 5-second blackout. This simple data, the duration of the occultation from different locations, allows scientists to reconstruct not just the asteroid's size, but its shape. They can determine if it is spherical, elongated, or even has a small moon of its own orbiting it. Capturing this event is a thrilling challenge. You are watching a specific star at a precise predicted time, knowing that a failure to see the blink means you were simply outside the shadow's narrow track. But when you are in the right place at the right time and that star abruptly disappears, you are not just seeing darkness. You are measuring a tiny world, participating directly in the science of discovery. It is the ultimate game of cosmic hide and seek, where your observations help map the silhouette of a distant, ancient rock. There is a pyramid of light waiting for you in the twilight. Long after sunset, when the last colors have faded from the western horizon, a faint, ethereal glow can sometimes be seen reaching up toward the stars. This is the zodiacal light, a vast celestial structure so subtle it is often mistaken for the lingering glow of a distant city. It appears as a soft, triangular pillar of light, tilted along the same path the sun and planets travel, a road of ghostly radiance ascending into the heavens. To see it is to witness a cosmic secret, the visible signature of our entire solar system's dusty foundation. The source of this gentle light is not a single star or planet, but trillions upon trillions of microscopic dust particles. These tiny grains, the leftover debris from asteroid collisions and the dusty tails of passing comets, form a colossal, lens-shaped cloud that envelops the sun and all the inner planets. Sunlight strikes these motes of interplanetary dust, scattering back toward Earth and creating this immense, luminous pyramid. You are essentially seeing the sun's reflection in the cosmic dust that fills the space between worlds. To have any hope of seeing this delicate phenomenon, you need a truly dark sky, far from the light pollution of towns and cities. The best times to look are during the spring evenings when the ecliptic, the plane of our solar system, stands nearly straight up after sunset, or during the autumn mornings before dawn. You must wait for a night with no moon and allow your eyes to become fully adapted to the darkness. Patience is your most important tool. Gaze toward the west about an hour after sunset, looking for a soft, broad cone of light that seems to hold the constellations within it. This faint bridge of light is not just a beautiful sight, it is a direct connection to the architecture of our solar system, a map of the flat disk where all the planets orbit. Seeing the zodiacal light is like seeing the foundation of a cathedral by the dust motes dancing in a sunbeam, a reminder that the space between planets is not empty, but filled with the fine, luminous powder of cosmic history. That same interplanetary dust that creates the zodiacal light holds one final, more elusive secret. Directly opposite the sun in the midnight sky lies a faint patch of luminosity so subtle it has earned the name Gegenschein, a German word meaning counterglow. This is not a pyramid of light, but a nearly imperceptible brightening in the darkness, an oval-shaped ghost of illumination that marks the point in space exactly behind Earth from the sun's perspective. While the zodiacal light is sunlight scattered at an angle, the Gegenschein is sunlight reflected directly back toward its source, a phenomenon called backscattering. The microscopic dust particles floating between the orbits of Mars and Jupiter act like countless tiny mirrors, all oriented to reflect a collective glow back along the sun's line of sight. To see it is to look into a cosmic mirror, observing the precise point where the dust of our solar system shines its brightest. Catching a glimpse of the Gegenschein is one of the ultimate challenges for an amateur astronomer. It demands the darkest possible skies, far from any city glow, on a night of exceptional atmospheric clarity when the air itself seems to vanish. You must be under a true inky black sky, and even then, the Gegenschein is so faint that it is often invisible to direct vision. The most reliable method is to use averted vision, looking slightly away from the spot to allow your eyes' more sensitive rod cells to detect the subtle contrast against the black of space. What you are searching for is not a defined object, but a faint brightening of the background darkness itself, a patch of sky that somehow seems less black than its surroundings. Its significance is profound. Successfully observing the Gegenschein does more than just complete a celestial trifecta of dust phenomena. For scientists, mapping its subtle shape and brightness provides a direct measurement of the density and distribution of interplanetary dust throughout the inner solar system. It reveals the structure of the cloud we all live within, a silent, dusty ecosystem born from the collisions of asteroids and the slow decay of comets. To stand under a pristine sky and finally discern that faint counterglow is to achieve a quiet communion with the fundamental structure of our cosmic neighborhood, seeing the invisible made momentarily real. For a brief, glorious era, humanity unknowingly seeded the sky with its own artificial stars. Iridium flares were a unique kind of magic, predictable bursts of light that could appear anywhere, outshining every planet but Venus for a few breathtaking seconds. These were not natural phenomena, but the result of brilliant engineering. The original Iridium communication satellites were built with 3 highly reflective, door-sized antenna panels. As these satellites tumbled in their orbits, there would be a perfect moment when one of these flat, polished surfaces caught the sunlight just right, acting like a celestial mirror aimed directly at a spot on the Earth below. The satellite itself was invisible, but its reflection would ignite into a dazzling point of light that would grow in intensity, peak with stunning brilliance, and then fade to nothing, all within 10 seconds. For anyone who knew when and where to look, it was a guaranteed performance. You could step into your backyard, watch an empty patch of sky, and see a new star flare into existence on cue, a silent man-made supernova. This created an intimate connection with the technology whirling overhead, transforming anonymous satellites into personal celestial beacons. The end of this era came as the original Iridium constellation was gradually replaced and the older satellites were deorbited, burning up in the atmosphere. The last classic Iridium flare was predicted and witnessed by thousands in 2019, a final collective farewell to a phenomenon that taught us to look up at our own creations with wonder. While those specific flares are now history, the principle remains. Other satellites with large, flat surfaces like the Blue Walker 3 prototype have already demonstrated they can produce flares even brighter than the original Iridium burst. The sky is not static, and as new constellations are launched, we are reminded that the most fleeting lights above can sometimes be our own. Our own moon offers a front row seat to cosmic collisions happening in real time. A lunar impact flash is a sudden, brilliant pinprick of light that appears on the moon's dark, unlit portion, the signature of a meteoroid hitting the surface at tens of thousands of miles per hour. Unlike Earth, the moon has no protective atmosphere to vaporize incoming space rocks. When one strikes, its immense kinetic energy is instantly converted into heat and light, creating a flash that can be bright enough to see through a backyard telescope. The best opportunities to witness this come during Earth's major meteor showers, like the Perseids or the Geminids. Astronomers know that if our planet is moving through a cloud of debris, the moon is too, and it faces the same incoming stream. By training telescopes on the moon's dark side during these showers, observers dramatically increase their chances of catching one of these fleeting explosions. The flashes themselves are incredibly brief, often lasting just a fraction of a second, a stark contrast to the slow, graceful events we usually associate with the night sky. Capturing one requires patience, a video camera attached to a telescope, and a lot of luck. But when you succeed, the reward is profound. You are not just seeing a flash, you are witnessing the creation of a new crater. Each impact excavates a fresh hole in the lunar soil, a permanent scar that slowly alters the face of our celestial neighbor. By monitoring these events, scientists can calculate the current rate of bombardment in the inner solar system, data that is vital for planning future lunar bases and understanding the risks to satellites in orbit. There is a unique thrill in knowing that the silent, ancient moon is still being actively shaped by forces we can sometimes see from our own backyards, a reminder that the solar system remains a dynamic and sometimes violent construction site. A comet can rewrite its own destiny in a single night. This is a comet outburst, a sudden and violent transformation that defies all prediction. One day it is a faint telescopic smudge, and the next it has erupted into a naked eye spectacle, its brightness increasing 1,000,000-fold in a matter of hours. The most stunning modern example is Comet Holmes. In October 2007, it was an obscure object requiring a large telescope to see. Then, within a single 24-hour period, it exploded in brightness. Its coma, the cloud of gas and dust around its nucleus, swelled to become larger than the Sun itself, a diffuse, glowing ball visible for weeks in the constellation Perseus. It was a cosmic flower that had bloomed overnight, a permanent change to the night sky that anyone could step outside and witness. The cause of such a dramatic event is not a gentle melting, but a catastrophic rupture. A comet's nucleus is a fragile conglomerate of ice, rock, and frozen gases, often compared to a dirty snowball. As it approaches the Sun and heats up, pressure can build beneath its crust. A massive section of its surface might suddenly collapse, exposing a vast reservoir of pristine ice to the vacuum of space. Or an entire section of the nucleus could split apart, a literal breaking point that releases an immense cloud of reflective dust and gas in a single, violent eruption. It is a geological event on a world of ice, an avalanche or a volcano that unleashes the comet's inner brilliance for all to see. The profound challenge for astronomers is that these outbursts are utterly unpredictable. They are internal revolutions hidden from our view until the moment they occur. We can track a comet's orbit with perfect precision, knowing exactly where it will be years in advance, but we cannot see the cracks forming deep within its heart. This makes every comet a potential sleeper agent, a quiet traveler that could, at any moment, decide to put on the performance of a lifetime. To witness one is to see the volatile nature of our solar system laid bare, a reminder that these icy wanderers are not serene, but dynamic and occasionally explosive worlds. The same celestial geometry that brings us the transit of Venus offers a more frequent, yet no less fascinating, performance from the Sun's innermost world. A transit of Mercury sees the smallest planet in our solar system pass directly between the Earth and our star, appearing as a perfectly round, ink-black speck inching its way across the vast solar face. Compared to the transit of Venus, this event is far more common, happening about 13 or 14 times each century. But do not let that frequency fool you into thinking it is any less significant. Mercury's diminutive size is the entire point of the spectacle. While Venus appears large enough to be seen as a distinct disk without magnification, Mercury is a true test of observation, a tiny punctuation mark against the Sun's brilliant backdrop. Its small stature is a direct and visible consequence of its place in the solar system, a rocky world not much larger than our moon, silhouetted against a star that is over 200,000 times its size. This stark contrast in scale is a humbling lesson in cosmic perspective, all contained within a single, slow-moving dot. To witness it safely, you cannot simply use eclipse glasses. Mercury is too small. You will need a telescope equipped with a proper, certified solar filter. Alternatively, you can use a projection method where the telescope's image is safely projected onto a white surface, allowing a small group to watch the event together. The next opportunities to see this miniature crossing will occur on November 13th, 2032, and then again on November 7th, 2039. Each transit is a slow, silent ballet lasting several hours, a chance to see the solar system's swiftest messenger caught in a perfect, temporary alignment, proving that even the smallest of worlds can cast the largest of shadows on our imagination. The moon's familiar rhythm holds a calendrical secret, a quirk of timekeeping that gives us a blue moon. This name has nothing to do with its color, a fact that often disappoints new stargazers. You will not see a sapphire disk in the sky. Instead, a blue moon is a story of mismatched cycles, a collision between our man-made calendars and the moon's timeless orbit. There are actually two definitions, and the older one might surprise you. Most people know the monthly blue moon, which is simply the second full moon to occur within a single calendar month. Since our months are roughly 30 days long, but the lunar cycle is 29.5 days, this timing occasionally lines up, giving January a full moon on the 1st and another on the 31st, for example. But the original, and some would argue truer, definition is the seasonal blue moon. An astronomical season, the time between a solstice and an equinox, typically has 3 full moons. Occasionally, a season will pack in 4. In that special case, the third full moon of the 4 is christened the blue moon. This archaic rule was once printed in the Maine Farmer's Almanac, and it keeps the named moons of the season, like the harvest moon or the hunter's moon, in their expected places. The phrase "once in a blue moon" speaks to its relative rarity. A monthly blue moon tends to appear once every 2 to 3 years, while the seasonal kind is slightly less frequent. This infrequency is what cemented the term in our language for any exceptionally rare event. The cultural weight of this calendrical anomaly is immense. It is a moment that feels both special and slightly off-script, a bonus full moon that does not quite fit the pattern. You can mark your calendar for the next occurrences. A monthly blue moon will rise on May 31st, 2026, and the next seasonal blue moon will grace the sky on August 19th, 2024. So when you hear that a blue moon is coming, do not look for a change in hue. Instead, appreciate it as a celestial correction, a subtle nod to the fact that our neat human schedules will always be gently, beautifully out of sync with the cosmos. Our own planet's eclipses are breathtaking, but they are merely one version of a cosmic phenomenon that plays out with stunning variety across the solar system. Imagine standing on the cracked, sulfurous plains of Jupiter's moon Io. The sky above you is dominated by an impossible sight, the colossal banded sphere of Jupiter. It is not a distant disk, but a world that fills half the heavens. As you watch, a perfect in-sky black circle begins to creep across the face of the sun. This is not our small moon casting its shadow, but the mighty Jupiter itself. The eclipse begins, and the giant planet's night side engulfs you in a profound darkness far deeper than any earthly night. You are not just in shadow, you are inside the shadow of a world. The sun, a distant star from this far out, is completely extinguished, and the true spectacle begins. Jupiter's upper atmosphere ignites into a ring of fire, a brilliant, glowing halo of auroral light encircling the entire planet. This is a total solar eclipse on an alien moon, a spectacle of scale and beauty that dwarfs our own experiences. The mechanics are the same, a perfect alignment of sun, planet, and moon, but the roles are reversed. On Earth, our small moon perfectly covers the large, distant sun. On a moon like Io, a gargantuan planet effortlessly blots out a tiny, shrunken sun. The same simple geometry creates an experience of vastly different grandeur. This celestial theater is not unique to Jupiter. From the hazy, orange skies of Saturn's Titan, you would witness Saturn itself, rings and all, slide in front of the sun. The eclipse would be a slow, majestic event, the planet's intricate ring system slicing across the solar disk, creating a complex, evolving pattern of shadows and light before totality plunges the methane lakes into an eerie twilight. These imagined vistas reveal that an eclipse is not a singular event, but a family of alignments. Every moon orbiting a gas giant experiences its own schedule of planetary eclipses, a constant, silent dance of shadows cast across frozen, alien landscapes. To contemplate this is to understand that the beautiful coincidence we witness on Earth is just one verse in a much longer, more diverse cosmic poem. From earthly eclipses to stellar explosions halfway across the universe, this journey reveals a cosmos of breathtaking diversity and profound rarity. Each event is a unique alignment of time, place, and perspective, a fleeting performance on a stage that spans light years. The clockwork of our solar system offers the patient choreography of transits and conjunctions, while the deeper universe delivers the sudden, violent poetry of gamma-ray bursts and stellar resurrections. These are not just lights in the sky, they are stories of gravity, light, and time, invitations to witness the dynamic forces that shape everything we see. To chase these spectacles is to become an active participant in the universe, not just a passive observer. Your most powerful tools are closer than you think. Modern astronomy apps can guide you to the next planetary alignment or meteor shower peak, turning your smartphone into a personal planetarium. Local astronomy clubs welcome newcomers, offering access to telescopes and the shared wisdom of experienced observers who know where to look. The most important instrument, however, is your own sense of wonder. Make a habit of looking up, learn the major constellations, watch the moon's phases, and you will begin to notice when something new, something extraordinary, has taken its place in the familiar tapestry. The sky is a live theater, and its greatest shows are waiting for you. We want to hear about your own cosmic moments. What sight forever changed your relationship with the night sky? Share your most memorable stargazing experience in the comments below. For more guides to the universe's wonders, subscribe and join us on the next cosmic adventure.